All right, let's get started with the demonstration. So for today's demonstration, I will be using the order processing workflow, which is the same use case that we discussed some time back. And I have the Visual Studio Code open here, and I've installed the Kogito Serverless Workflow extension. And then I've also got a serverless logic project open here, which is a simple Maven project with a standard structure. And I have a order.sw.json file contained within the src main resources folder. And the Kogito Serverless Workflow extension, the VS Code extension, it recognizes the files with the extension .sw.json, and it automatically opens up the relevant editor so that we can define the workflow and see the visualization as well. So the right side shows the visualization of the workflow, and the left side is where we define the serverless workflow. Okay, so let's take a quick look at the workflow definition. The workflow starts as soon as it receives an order. There is an order received event. So this is an event state where it expects a cloud event. And once that event is received, the control goes to the next step where it checks for the availability of the item in our local inventory. So for example, we have two different ways of provisioning the items. So one is an internal inventory and the other one is an external supplier. So if the item is available within the internal inventory, the control flow will go through this path. Otherwise, we will take the help of an external supplier to get the item that's there as a part of the order. And irrespective of whether the control goes through this path or this path, the next step where it has to wait is in this step, which is once again an event state. And what happens here is that the control flow will wait for the completion of the shipment. So once it receives a shipment completion event, then the control flow will go to the next step. Now, there is another possibility as well while we are waiting for the shipment to happen. So before the shipment could happen, the customer could change his mind for various reasons, and he might cancel the order as well. So the same event state could also receive a cancellation event if in case the customer wants to cancel the order. So that's the two different types of events that that the workflow could receive when the control is waiting in this particular state. Now, what happens after that is depending on the type of the event that comes in. If the event received is a shipment completed event, then the control flow will go through this path. Otherwise, if the event received is a cancellation one, then the control flow will go through this path. Now, the interesting part here is about this state, which is called the compensate order. Now, what happens is, even in case if the customer has canceled the order, now we have to roll back or we have to compensate for all the other executions that has happened previously before the control has come to this path. Just for example, let's assume that the control flow has come through this path where we have actually tried to provision the item from an internal warehouse. Now, what has to happen is we would have already detected the item from the internal warehouse. Now, a compensation has to happen so that we can restore the inventory back into the warehouse. So that kind of a compensation has to happen, and this step actually indicates the workflow by a specific mechanism. For example, here if we see compensate is equal to true, then it triggers the workflow compensation automatically. Now the workflow engine knows what was the execution path that it had taken before the control came here, and it will execute the relevant compensation for those steps. Now, for example, taking the same use case where the control flow has come through this step or this state, we know that we have a compensation attached with it here. So the compensations attached with each of the steps are denoted by orange dotted lines here, as we can see. So in this case, restore inventory is the compensation for this state, whereas we have cancel supplier order as the compensation for this state. Now the workflow engine knows the path of execution that it had taken, and so it will call the corresponding compensation without we having to explicitly say which is the compensation that has to be executed. And similar to that, I mean, these states, for example, forward to external supplier is a state where we would be invoking an external REST API in order to provision the order to an external supplier. So in that case, for various reasons, the REST API call could fail. Now, how do we handle the errors and exceptions that might occur during the invocation of the REST APIs? Now, serverless workflow also provides the ability to model error definitions, and we can link the error definitions to the specific states where such an error could happen. Now, with that, what happens is the serverless workflow would be able to catch those exceptions and errors, and it can execute the relevant handling of that exception. For example, in this case, whenever an exception happens in this step, the control flow goes through the service error step where we log the specific error message, and then we send a notification to the relevant teams, and then we end the workflow. So let's take a quick look at the definition of these compensations and error handling. So for example, if we go to the prepare for internal shipping step, we see that we have a compensation reference here. For example, we say that compensated by the step which is going to be restore inventory, and that automatically provides this linkage. And similarly, if we go to the forward to external supplier, we will also see that a similar compensated by definition is also there. And not just that, for this step, as I mentioned, we also have an error definition, which means there is a potential possibility that an error can happen. And so those error handling definitions could be specified by the relevant metadata here. And we have an error reference here as well here. So the errors are defined upfront, and the error definitions are typically linked. So for example, if we go here, this is the error definition, and that says there is a com red hat RHT exception, service exception. So whenever this exception happens, the workflow engine knows that this is the error, and it automatically refers the error reference and execute the course of action depending upon how it is modeled here. And another important aspect is about the ability to use, for example, the JQ expressions. So in this step, if we look at check inventory, we are doing a basic check here using JQ to see whether the order quantity has a 0 in it, which means if the order quantity is 10 or 100 or 1,000, then it knows that this test passes through, and for example, the control flow goes through this path. However, if it doesn't, then it goes through this path. So this is simple, a basic JQ expression. Similar to this, we can use any kind of JQ expressions within the workflow in order to check the data for the required conditions. And with that, I think we have had a look at the workflow definition. Now let's go ahead and run this specific workflow. And in order to run the workflow, so I'm going to run it in a developer in the developer mode. So what we can do is we can use the Quarkus CLI. So I'm going to say Quarkus dev, and when we do that, it's going to automatically start up the application. And as a part of the startup, it's going to do two important things. So the serverless workflow or the serverless logic has got the ability to automatically spin up required ephemeral or temporary containers which are required for the execution. So if you recall, I mentioned about some of the supporting services like the data index, the management service, the job service, and so on. So the required containers are automatically started up here. As you can see, it starts up the embedded Postgres as well. Again, Postgres is the one that provides the data persistence for serverless logic. So it starts up the required container for that. It also starts up a data index container. So if I go back to the Docker desktop, you can see that a Postgres container is running, and it's also running a data index container as well. So yeah, all of this happens as a part of the startup. So now it has all started up, and it's ready to receive the requests. So let's go ahead and start a new workflow, and I'm going to use some of the existing probes in order to do that. So let's start the workflow, and as you can see, this we are going to start the workflow by sending a cloud event. So you can see the relevant information that's required for defining the cloud event. We are going to pass a specific payload as well. So let's execute this request, and yeah, so the serverless workflow engine has received the request. Now, how do we know what has happened to the request? So there are two ways to do it, to check that. For example, since we have enabled suitable logging, we can see that the relevant information is logged here. To start with, for example, the workflow engine has received this payload, and it executed various steps. For example, it started the order from the order event state, and then it updated the relevant properties. For example, the workflow data item has been updated to 222, which was part of the input payload. And then the other steps were executed, checking of the inventory, and then forwarding to the external supplier, and so on and so forth. So this is more from the logging point of view, each of the different steps that were executed as a part of the workflow are logged. Now we can also look at this from a more graphical perspective if we go to the management service. So let's go to the management service, and if we go to the management service, let me refresh this, and we will see that we have the workflow which is already started. So let me open up to this workflow, and we will see that this is the workflow that has already triggered, and what are the different steps that have got executed as a part of the workflow. That is also shown here. So we see that the order event was received, it went through the check inventory, forwarding to the external supplier, and the control is right now waiting for an event to happen. It could be a shipping event or it could be a cancellation event, but it's waiting for that event to happen. Now let's send a message so that the workflow continues forward. All right, so let's send a shipping event. So happy path. So I'm sending a shipping event. And once the workflow receives this event, so I hope it has already received. So let's do a refresh. And if we go down the path, we will see that the order is already shipped. The shipment is completed. So it has notified the customer and the workflow has ended. And that's also something that we can see graphically here as well. So the workflow execution path is ideally shown here, but it's not highlighted at the moment. But definitely I think the future releases will have the highlight option as well, where it will show the path of execution that the workflow has taken. And it also shows the variables that were updated as a part of the workflow execution, and the other metadata about the workflow as well. Now, we also talked about the data index. So for example, if we go back here, so it also provides a data index API. So all of these are available as a part of the Quarkus Dev UI tools. So for example, if I go back to the Dev UI console, we can see that we have the data index specific interface, and also the monitoring interface as well, or the management interface as well. All right, so this is the GraphQL UI that's part of the data index service of serverless logic. So for example, we can query different states of the workflow by defining the relevant GraphQL query, and this is the data index service that the management service is internally using in order to get the workflow details and show it as a part of the monitoring console. All right, so now let's go ahead and execute some more requests just to talk about the different possibilities, especially the error handling. Let's look at the error handling. So for example, now we are going to start a specific workflow, which is intentionally we are going to fail that workflow with a service exception, and the workflow has been internally, the API is defined in a way that whenever the flag that comes, these two flags are coming as true, it's automatically going to throw that service exception that we had seen. So yeah, so let's send this request so that the workflow, when it invokes the API, is going to receive a service exception, and the execution is going to take the path which it should go through when the exception happens. So let me send this request, and let's go back to the console. And if we take a look at the workflow, so this is the new workflow that has been completed few seconds back. And if we open up this workflow, and if we go down the timeline, we will see that the control flow has went to all the required steps, and when it went to the forward to external supplier, there was this exception, service exception, that had happened, and as a result of that, the course of execution the workflow took was to the steps called service error and failure notification. So this is how the exceptions are handled. Now again, going back to another scenario which could potentially happen is about the cancellation. So when the workflow is waiting for the shipment to happen, let's say the customer changes their mind and they submit a cancellation order, for example, cancellation event. So let me send this request again. And if we go back to the console once again, going back to the workflows, so this is the latest workflow that has got started. And if I go down, we can see that the the specific workflow is waiting for either the cancel event or the shipment event to arrive. And now let's go ahead and send a cancel event. So let me send a cancel event. And if we go back to the workflow and do a refresh, we will see that the relevant compensations would have got triggered. So if you recall, we had a compensation since the course of execution was through this forward to external supplier. The compensation that's expected to have happened because of the cancellation is cancel supplier order. So let's go down and see what has happened. So if you see here, it was going through the step for forward to external supplier, and then it was waiting for an event, but then it received an event which is for cancellation, and then it has went to the step called compensate order. And the compensate order, due to that execution, the workflow engine knows that it has to execute the compensation, which is called cancel supplier order, and then it executed that and it has ended the workflow. Now, this is how the entire workflow engine works. And of course, many of these different components like the serverless, serverless logic, the monitoring dashboard, and also the data index. So these elements are not yet still there as a part of Openshift. However, let's go ahead and deploy the application into Openshift and see how does it look like. So in order to deploy the application to Openshift, we follow the standard procedure, which is basically the creation of the image. So first we build the image for this application using the standard Quarkus extensions, and in this case, for example, we're going to build it and send and put the image in Quay. And once the image is available in Quay, all what we need to do is just use the KN CLI, the Knative CLI, in order to create the application and run it as a Knative service. So in the interest of time, I've already done this. So let's directly go to the Openshift console. And if we go to the console, we see that the application is already there. And I've also provisioned a Postgres database so that it provides the required persistence for this application that we have deployed. So now the application is already scaled down to 0. So let's send a request so that we are able to execute the same workflow on Openshift. So let me go back again to the probe and let's send this request, which is going to send again the same order creation, but now to the application that's deployed on Openshift. So let me send this request, and let's see that the pod is already starting to run, and we can see that it's already up and running. If we go to the logs, we will see that it has already started the execution. So it started the new process. It went to the step check inventory, and then it went to the step called prepare for shipping. Now in this example, depending upon the payload, the workflow is taking the other path of execution where it's not going to the external supplier, it's going to the internal supplier. So the internal supplier has received the order. Now let's execute the same scenario where we will cancel the request. So if we cancel the request or cancel the order, now what would happen is automatically it would trigger the compensation. As we can see, it has triggered the compensation. And in this case, the compensation is going to be cancel internal order, because this is the compensation step that is linked to the internal shipping event. Let me just bring up that again just to show that restore inventory. So this is the step where we are printing this message cancel internal order, and this one is the compensation that it has to execute when we have the prepare for internal shipping step. So this is how it actually works on Openshift as well. And as I mentioned, we don't have the management service and the data index parts fully ready for Openshift, but it's going to be there in the near future very soon. And another important thing that I just wanted to show is about something what we call as the serverless logic web tools. So if you go to start.cubesmarts.org, which is the online web tooling for serverless logic, we will see that it provides the ability to create the serverless workflow here, and we can do the testing as well from here itself. Let me show a quick example of that. So for example, let me just click on one of the existing workflow definitions, which is basically a greeting workflow. And here as well, we see that a similar kind of experience is there, where we have the definition console on the left and the visualization console on the right side. And yeah, we can define the workflow here itself without having the need to install any of the tools locally on the desktop. So we can develop the workflow directly on the web UI itself. Now, let's say once the workflow is defined, we want to directly test it on Openshift. We could directly do that by clicking on this icon and then just say deploy application. Now, I have already made the configuration to connect the application to Openshift. So I've already made the required configurations here. And as a result of that, I can just click on deploy greetings, and the workflow will get deployed into my Openshift cluster. Now, again, in the interest of time, I've already done the deployment. So if we go back to the topology, and if we take a look at the applications here, we will see that the application is already deployed. You can see that it's deployed from the web tools. So this application is already up and ready for serving the required needs. And not just that, as usual, like we can go to the specific a URL provided by this application, and we have the Swagger UI from where, for example, we could trigger the application execution. So let me just go ahead and open up the specific application, Swagger UI. So we have a JSON greet as the endpoint provided by that application, and we can just specify a sample here. So this application is going to provide a response, a greeting message based on the input that we are providing here. So if the language is Spanish, it's going to provide the response in Spanish. So let's try it out. So let's execute this, and we see that we get a greeting message back in Spanish. So that's how it works, the overall end-to-end deployment cycle from the serverless logic web tools. With that, we have come to the end of this demonstration.